All right, so today we're diving headfirst into, well, black holes.
They are fascinating, aren't they?
Totally. And the thing is, we're not just talking about them sucking stuff up. That's like black holes 101, right?
Right.
What we're looking at today is how they shoot stuff OUT. We knew about these jets before,
Yeah.
but we're talking way bigger, like way, way bigger than we thought was possible.
It really makes you rethink what you thought you knew,
Yeah,
about these things. It seems counterintuitive, right? Black holes pull everything in,
exact.
and yet they can shoot out these incredibly powerful, just massive jets of energy and matter, too, that stretch out across millions of light years.
It's mind-boggling. So that brings us to what we're really looking at today, a newly discovered jet system. They're calling it Porphyrion.
Porphyrion.
Yeah, Porphyrion. And
Quite a name.
it is.
A fitting name, I think. In Greek mythology, Porphyrion was this giant who, he challenged the gods.
Oh,
And this jet system, it's certainly challenging our cosmic perspectives.
yeah. To put it lightly, we're talking about a jet so vast it makes, our own
The
galaxy.
Milky Way?
Yeah, the
Yeah.
Milky Way. It makes it look like a speck of dust. Like if our galaxy were the size of a house, this jet would be stretching for miles. It's wild. And we're going to break it all down today, all the details from this Sky and Telescope article we have. But before we get too far, can you just give us a quick, black hole jets 101? How do they even work? Because it's not like stuff can just fly OUT of a black hole.
Well, not quite. It all starts with what's going on around a black hole. You've got a supermassive black hole.
Millions, billions of times the mass of our sun.
Exactly. And it sits there at the center of a galaxy, usually. And surrounding it is this swirling disk of gas. Superheated gas, we call it accretion disk.
Okay, so it's like a cosmic whirlpool.
Yeah, you can think of it like that. And as all this gas gets pulled closer, things get really, really extreme.
Because everything's spinning faster and faster.
Right. The particles are moving so fast that they generate these powerful magnetic fields.
Okay.
And those fields, they act like a particle accelerator, basically.
Oh, wow.
They funnel some of that gas, that superheated gas, away from the black hole.
That's like mouth, basically.
Yeah, it's maw. And they focus it into these incredibly powerful jets. And those jets, they shoot out from the black hole's poles.
So instead of falling in N, some of it gets channeled OUT
Precisely.
at insane speeds.
Nearly the speed of light.
Nearly the speed of light. That's just mind-boggling on its own, but these jets stretch for millions of light years. How can we even see them from that far away?
That's the amazing thing. We can observe these jets in radio wavelengths.
Radio waves.
Yes. The particles in those jets, they're moving so fast that they emit these radio waves, and we can pick them up here on Earth.
Wow.
By studying them, we can figure out the speed of the jet, its energy, even what it's made of.
So it's like we're listening to the black hole in a way.
Exactly.
Wild. But, okay, so we've got these jets shooting out, right?
Yeah.
And in the case of Porphyrion, we see this thing, it's called the Kelvin-Helmholtz instability.
Right.
And from what I understand, it's like this should be disrupting these jets,
Yeah, you'd think so.
not making them bigger. So what is that exactly?
Okay, so picture this. You've got a strong wind blowing over a lake, right?
Okay.
What happens? You get waves.
Right.
That's essentially the Kelvin-Helmholtz instability.
So two things moving past each other at different speeds.
Exactly. And those different speeds create those wave patterns.
Yeah.
In space, those two things are the jet, which is superheated plasma moving crazy fast,
Right.
and then the interstellar and intergalactic medium, which is, well, everything else. Much cooler, much less dense.
So you're saying something should be breaking up this jet, stopping it from getting so big.
That's what we'd expect, yes.
But that's not happening with Porphyrion, so what's going on?
That's the million-dollar question. And the answer lies in something called cosmic voids. Imagine like a giant spider web.
Okay.
That's kind of what the universe is like. These threads of gas and dark matter connecting galaxies and clusters, stretching out over, well, ridiculous distances.
I'm with you.
Now, imagine there are regions in this web, but they're practically empty. Like giant cosmic bubbles. We call those cosmic voids.
Cosmic voids, okay.
And that's where Porphyrion gets interesting. It looks like it's punching its way right through one of them.
Oh. So instead of getting all broken up traveling through space, this jet is basically flying through, well, nothing.
Pretty much. The article says Porphyrion's jet, it's going through an area of space that has way lower gas density. And that, well, it weakens the Kelvin-Helmholtz instability.
So it can stay together and keep growing.
Exactly. That's why it's so long. And we're not just guessing here. The researchers actually observed this, the lack of disruption. They used radio waves.
Okay, so how do radio waves show that?
Well, the signal from Porphyrion's jet, it's really smooth and consistent. If it had been hit by the instability, it would be messed up,
Yeah.
but it's not.
So that makes
And it hasn't been significantly affected. It's just been cruising through this void.
this is unbelievable. I mean, we've never seen anything like this before. Does this change how we look at all black hole jets? I mean, in general.
It definitely adds another piece to the puzzle.
Because we knew about cosmic voids, right?
It did, but we didn't know they could do this, how they could impact these jets. But Porphyrion's telling us something. It's telling us that these voids, they might be, like, essential to forming the universe's largest, most powerful jets.
It's like we found some artifact, but it's rewritten history. Except the artifact is this insane jet of plasma that's longer than, like, I don't even know.
Longer than our galaxy.
Longer than our galaxy. Okay, sorry. I'm getting a little carried away. This is just, it's wild.
It puts things in perspective.
Yeah.
And speaking of perspective, we can't forget about the black hole itself.
Right.
The article mentions something interesting. For Porphyrion's jet to get this big, the black hole, it had to be running for a long time. And I mean a long time.
Like how long?
Billions of years, possibly.
Billions of years. Our solar system is, what, nothing on that time scale?
Exactly. That whole time, this black hole's been eating matter and shooting out these jets.
It's like a cosmic beacon. But it's sending radio waves, not light. But hold on, let's zoom out a bit. So these jets, they form. Porphyrion's is unique, all that. But what does it mean for, like, the rest of the universe?
Yeah.
What can these jets, especially ones this massive, actually do?
That's the question that keeps astrophysicists up at night. It's like they're power lines, these jets, but they're transferring energy across millions of light years.
Okay.
And that energy, that superheated plasma, it interacts with stuff, gases, galaxies. And when that happens, well, it can really shake things up.
So they're not just pretty then?
Oh, no. They can change how the universe evolves.
Wow. How?
Remember the cosmic web we talked about? These jets, they heat up the gas in that web.
Oh. Okay.
And that affects how matter clumps together, which is how galaxies form.
Whoa. So they can stop galaxies from forming?
They could. Or change how they're shaped, how big they get.
So these jets are like...
Sculpting the universe.
Yeah. That's incredible. Imagine if one jet can do that. What about all of them?
Oh,
For billions of years.
that's what we're trying to figure out.
It's insane.
It really is. But there's another thing about these jets that's super interesting.
What's
It
that?
has to do with magnetism.
Magnetism. Okay, now I'm really interested. Okay, so magnetism. What's the connection with black hole jets?
Well, it's like this, right? Planets, stars, galaxies, even the space between them, it's all got magnetic fields.
Right.
But where they all come from, that's been a bit of a head-scratcher.
Yeah.
And this is where black hole jets get really interesting. Think of it like this. Imagine these tiny, tiny seed magnetic fields way back in the early universe.
Okay, like little seeds.
Exactly. And these seeds, they grow into the big magnetic fields we see everywhere today. But for that to happen, something had to make them grow. Something had to stir things up and give them a boost.
Okay, so what gave them that boost?
That's where the black holes come in. These jets, they could be carrying these magnetic fields and spreading them around as they blast through space.
So they're like cosmic gardeners spreading magnetic seeds everywhere they go.
That's a great way to put it. And these seeds, they interact with the gas and galaxies around them, and over time they grow into these big, powerful magnetic fields we see today.
Wow. It's amazing how these incredibly powerful events, these black holes and their jets, are connected to like the very fabric of the universe. It's like a chain reaction starting from a single point and then influencing everything.
It's a pretty incredible thought, isn't it? And it really shows how much we still have to learn about the universe.
Absolutely. With every discovery, we get a little closer to understanding these mind-boggling processes, which, speaking of discoveries, brings us to our final thought for today. We talked about how Porphyrion's black hole had to be active for like billions of years to create such a massive jet. So could there be even larger jets out there? Jets from even older black holes hiding in the universe, just waiting to be found? What could those jets tell us about the early universe?
Now that's something to ponder, isn't it? It's a good reminder that we're just scratching the surface. The universe is full of wonders, and who knows what we'll discover next.
It's humbling and inspiring at the same time. Well, on that note, thanks for joining us for this deep dive into the incredible world of black hole jets. Until next time, keep looking up and keep those questions coming.